In this video, we will continue on the beginner's guide to SDL2 in the fourth language. We will be using G4 for this. This is the third video, so if you're just starting with this video, you're going to want to go to github.com, Programming Rainbow, Beginner's Guide to SDL2 and G4. You're going to want to clone that repository, and we can use the source code that will be in video number 2, the last video we did. If you grab that source code, which is main.fs, and copy it to the top level directory, you'll be where we are in this video. So I want to show where we left off with in the last video, and then I want to talk about a little fix from the last video. Okay, so in the last video, we have this 800 by 600 window that we open up. It has a title up here called Close Window, and if we press Escape like this, or if we tell it to close, it closes now. So it's running at roughly 60 times a second. And we have a game loop in place and we are checking events. Okay, so that's where we ended off in the last video. I want to correct the way I was setting it up in the last video. So let's just look at this real quick. So specifically when we're talking about the, okay, so we have the keyboard event type, right? First thing we do is we check the type, but then we are interested in what key was actually pressed. So we changed to using the offset here. The problem with this is this is actually another struct inside of this struct. So this is a struct that's inside of the enum, but this is another struct inside of it. Okay, so when we, and it's down here, if we go click on this, what's inside of here is, again, so we've already going to offset for this struct, but then there is another side of it that is the scan code. Okay, so it's not shown very well here, but I will show it in my bindings. Okay, so in the events, the way the offset, this is the actual fourth bindings that I've created. So if we go down to keyboard events, the first thing, we already know the type of it. We've already got the type, but now we use the offset to get to the key sim. And I was trying to look to see if this was a 32-bit signed or unsigned, and I wasn't getting the answer. This was redirecting me somewhere else. It's actually getting the size of another struct that's over here. And so the first member of this is actually the scan code. So if we wanted to, now this still works without doing it. I want to tell you my original code did work, but there's two issues with it. The first one is see, since when we go to get this, where is it? Not window event, sorry. It should be keyboard event. When we use this offset right here, we were using this to just pull what keyboard press was pressed. And this does work because the very first, if we use this address here, the very first member of this is actually what we want. So if we were to get the address offset of the scan code, it would actually just be the same address. So that still works even though it's not literally proper. But also this is a signed 32-bit int, not an unsigned one. And we were doing an unsigned fetch. So again, it still works because it wasn't a negative number, but it's not correct. And we should really be careful with the signed and unsigned fetches from C. So the original code, sorry, right here, the original code that I was using right here looks something like this. So this is what it looked like. So what we were doing here is we were throwing event on the stack, the address, and then we're getting the offset to the key sim. And what we really need is the offset to the scan code, but we can't do that directly against event. So we need to get the offset of key sim and then get the offset of scan code. The reason why it worked the original time is because this actually doesn't offset. It actually doesn't do anything. So whatever this memory address is, this is still going to be the first member. So it's going to be the same memory address. So you don't have to put this in, but you really should because you are actually trying to get to this scan code. So just to be safe, you should do it this way. Also, it is not an unsigned 32-bit. It is a signed 32-bit. So it was working for us because the numbers were positive, but that's quite dangerous there because we could get a totally different number if for some reason we got a negative number out of here. And it's going to turn into an unsigned number, and you're going to end up with like 4.3 billion plus number. So again, the original code was just event SDL keyboard event key sim, and which wasn't quite right because I wouldn't even do that in C. I would actually be doing this member. I would do this member and then this member. So it would look like this in C. It would be like key sim and then scan code. And that's what if I was in C, that's what it would look like to me. So here, I don't need to do the key. I can go straight to the key sim, but once that address has been changed, we need to change it again to the scan code one. And also the fetch here is a signed fetch. So make sure that you have the SL. I've fixed this on the GitHub. And it's fixed in all the videos moving forward. So I just want to explain what was happening there. It still worked in the original one, but it wasn't right two different ways. For one, even though this doesn't change the address, you should do this. But this definitely is a problem. You do want to always make sure when you're interfacing with things that are not forth in origins, like a 32-bit signed and unsigned ints coming from C, you really need to fetch the correct one. Because when it goes wrong, it goes, very wrong. So what I'm going to do here is I'm going to stick this on the next line down just for ease of readability. It doesn't really mean anything. It still operates the same. But that's what I wanted to explain there. So this was event keyboard SDL keyboard event keysim, and I was doing it L fetch, but now it's properly changing the address again to the scan code and do an SL fetch. Okay? And it doesn't actually affect the way the program was still closed before, but it is more correct now, and you shouldn't have any errors moving forward in the future with it. Okay, so hopefully that made sense. Let me just run it one last time. Okay, and I'm just going to press escape. Okay, so what we're doing with this video is we want to actually load an image, and SDL gives us the ability to load bitmap images, but it doesn't give us the ability to load non-bitmap images like PNG, JPEG images, things like that. But there is another module for SDL2 called SDL2_image that actually gives us the ability to load other image types. So we have the ability in SDL2 to actually create surfaces or textures, the software rendering or the hardware accelerated images, but we don't have the ability to load any kind of image other than a bitmap image. So we need to use this SDL image library to help us load images that are PNG or JPEG or TIFF, things like that. So where we are here is we need to initialize this image module. So to do that, it's image init, and to shut it down is image quit. We do need to get into a little bit depth onto what these flags are here. So these flags there are a number under the hood that's encoded what SDL, it's going to tell SDL which things should be turned on. So these can be ORed together, and that is a bitwise OR operation. So you can string multiple ones. You can say, I want JPEG turned on, I want PNG, I want TIFF turned on, and you can OR them to put multiple flags together. And it becomes even more interesting because the way that it tells us what flags were turned on, it returns it as this int value, this 32-bit signed int back onto the stack. And so we actually need to mask this answer before we can check it. So I'm going to have to explain this a little bit, what's going on here. So imagine we have some kind of encoding that says what flags we want on. So imagine we have a 4-bit number. I'm just making this up, but we have different images. We have BMP, we have JPEG, we have PNG, and we have TIFF. Again, I'm just making this up. But let's say if we want BMP turned on, then it is something like this. It's 1000. And if we want JPEG, it is 0100. You get the idea? 0010 for PNG and 0001 for TIFF. Okay, so if we wanted to turn all of these on, if we just added these together, well, that's going to be weird because this is a value of 1, this is a value of 2, this is a 4 and this is 8, right? So this value would be 8, 12, 14, 15, right? This would be a value of 15. So this is a poor example. I should do this right here. Okay? Because we don't know if it's exclusively none of the other bits are turned on. So in this one, we have a 8, a 9, right? We have a 9. And then on this one, we have a 5. And this one, we have a 3. And this one, we have a 1. Okay? So if we were add these together, we'd get 14, 17, 18, right? That would be the answer if we just added them. Assuming my math is proper, that's 8, 9, yeah, 18. But if we did a logical OR on these, what the answer is going to be is this. It's going to be, right? That's going to be the answer, and that is 15. Okay, so a logical OR says 1 or 1 or 1 or 1 is 1. And then it says 0 or 0, that's still 0, or 1 is 1 now, or 0 is still 1. So that's 1. 0 or 1 or 0 or 0. If any of them are 1, it's 1. See? So this allows us to, if however these numbers are coded, we can do a bitwise OR. This is a bitwise OR, okay? And then the problem comes in what if we need to know the answer? So what if we tell it that we want these first two turned on, right? So we say, I want these two turned on. So the answer to these two is 1, 1, 0, 1, right? That's right. So I put that on the stack. I call my image init, right? And when I get on the stack is say something like this. This is my answer back. And I need to know if what I wanted turned on is turned on. So I need to know, I can't compare this to this because they're not equal. But that's not what I need to do. I need to know is all of these bits that I asked to be turned on, turned on. So the way I could do that is I could use a bitwise AND. I could do, I could put this, here, and in fourth I could do and this would mask out. This would only give me bits turned on if both of them are turned on. So I'd end up with 1101 is my answer, and then I could throw my original thing back on the stack again, what I wanted, and I could compare them. And that would give me my answer. So I have something I'm passing in. This is coming back onto the stack. I put this onto the stack myself, and I do a bitwise and that masks my answer. It sanitizes what I want to know out of it. And then I put my original answer back on the stack. Well, sorry, the and, this is the answer from the and is what I'm showing. And then I'm putting this back on to compare. Now imagine my answer back was something like this. So the answer, if I have this number as my answer on the stack from this word, and this was the original one I wanted, so I throw it back onto the stack and do an AND operation. This is a bitwise AND. My answer from this would be 0 and 1 is going to be 0. That's a bitwise thing. They both have to be on for AND to spit out a 1. And then 1 and 1 is 1. 1 and 0 is going to be 0. And 1 and 1 is 1. So this is my answer back from my mask. This is me, the answer. This is what I wanted. This is me masking it. This is my mask answer. And this is, again, what I wanted now. And I can, so we have to do this multi-step thing. I hope this makes sense, but basically we can encode what we want. We pass it into the word here. We get an answer back, but the answer could be what we wanted, or it could be more than what we wanted. But all we care about are the bits that we initially wanted, are they turned on? So we have to use this mask to find that out, and then we finally get to compare that masked answer to what we originally wanted. So this is why I have pulled this information out into up here when I did SDL init everything. This is why I pulled this out, because we need image init, and I need to use PNG images. But you may want other images, okay? So I say constant and I say image flags. Okay, so this is going to become a very big pain in the butt if I were to use multiple. I have to use the multiples over and over again to check it. But right up here, since I have it up here, if you wanted, say JPEG, you could say image init JPEG, and you could say OR. And that will OR these two together. And basically you'll have PNG and JPEG turned on. I know we're using AND, but the bitwise operation is OR. And that will be held in this constant. And we'll be able to put the constant here, the constant here, and the constant here. Instead of these three things with the OR, all three of them would have to be here, and then all three would have to be here, and all three would have to be here. That would be too complicated. So that's why this is pulled out up here. Now I don't need to load JPEG, so I'm going to remove the OR, and I just need PNG. But if you wanted to add TIFF, JPEG, or whatever, you had other images, you could just do it right here, and you're holding it in this image flags word, and then you can use that. So we're going to see this thing right here. I'm going to make it right now. That's a long-winded answer. I hope it made sense. So what we're going to do is we already know just real quick, we know that this word that we need to call needs the flags on the stack, which we've created a constant to hold the flag we want, which is PNG. And we're going to get an answer back, which is the flags that were initialized. We don't know if they're the ones we wanted or not, but they're the ones that the word actually initialized. So we have to check that. So here we go, right down here. So I'm going to put on the stack the image flags. And then I'm going to call the word image init. Now, again, it's going to receive back onto the stack the answer. But I don't know if that answer is the answer I want, so I'm going to mask it with an AND. Notes, make sure I write it all correctly. So I'm going to put back onto the stack these image flags. So just understand, these flags are on the stack. This is consuming those flags and putting back onto the stack what flags were turned on. Now I am going to so there's just one thing on the stack right now, it's the answer. Now I'm going to add to the stack what I initially wanted, which is the image flags. And I'm going to AND them, and that's going to mask out the answer that this gave with what I wanted. So now I'm going to have what were the flags I wanted turned on. So again, I'm going to put back onto the stack the image flags, so I can compare that with the answer that came out of the AND. And what I want to know is not if it's equal, but if it's not equal. If it's not equal, something went wrong. So I'm going to use this right here, which is a not equal. Okay, so that's going to be if it doesn't equal my flags, then something went wrong. So, and actually, if it put on other things, other flags, that's fine, as long as all the flags I asked to be turned on are turned on. If it turned on other flags too, that's not going to error because I'm masking them out right here. I'm masking anything I don't care about out. Only the things I care about are coming from here, and then I'm checking those. So we'll create our error message. Error initializing SDL underscore image. That's the actual C name for the module that we are initializing. And we need to call error. That'll work. And then we need the then. Okay, so that I know that was very long-winded, but that is how we do it. We have the flags 1, 2, 3 times on the stack. So it's very nice that we're holding them here. If we had multiple ones, we'd have to put the multiples all 3 times on. And the way we shut it down, I'm going to do it in reverse order since I'm shutting down SDL quit last. And the last thing I just started up was image. I'm going to first shut down image. So image quit. That's how we shut that down. Now this is online, so it's going to give us access to the next function, which is this image load texture. And what this allows us to do is this allows us to load an image, which is going to be a PNG for us right here. This is going to be a string to where the image is. and we need the renderer on the stack too. So the renderer is on the stack, and then the actual image location, the file location, is going to be on the stack, and it's going to load this directly, not as a surface, but as a texture. The texture is important. This is a GPU texture. This is accelerated. This is going to be, if we have GPU acceleration, this is going to make it draw faster for us. And it's returning onto the stack the address of the SDL texture. So we're going to store this in a word right here, and we'll just call it background. So up here, I'm going to make a background. So we'll put null value background. Okay, so no value background. And what I'm going to do is I'm not going to put it in this initialize SDL. I'm going to create a new word called load media. And I'm not going to take anything off the stack. Nothing needs to be on the stack to run this, and nothing is put back on the stack. I mean, there could be things on the stack, but it's not consuming anything. Okay, and what I'm going to do here is I need the renderer on the stack, so we can just do that. Not require. There's the renderer on the stack, and the next thing that needs to be on the stack is a C-style string to the location of the file. So to do that, I do S and I do backslash because I need the escape sequence, right? And let's show the actual file that we're going to load. So I'm going to just close this. This is when we're talking about that. I'm actually going to come over here and close these as well. Okay, there we go. Okay, so the image is in the images folder, and what we want to load is the background PNG. So this is going to be a relative path since we're launching this from here, the images folder, and then background.png is inside of that. So right here, what I'm going to do is write images / background.png, and then we need to make this a null terminated string because this is going into a C function. So I do the \0. That's why we use the S backslash word. And also I need to drop the length because it's a C style string, not a forth style string. So the length that forth puts on, I'm going to drop that. So now I have the render and the C string. So the word we call is not SDL, image load texture. And what it's going to put on the stack is the address to the image. So since that's on the stack, I'm going to move that into our background word. So I'm going to say to background. Now I'm going to show you another way to do this. If you want to use variables instead of this kind of background word, whatever this thing is called, I'm not sure the technical term for this, but I believe this is a word in the dictionary with a value in it. But we can do a variable instead, and I'll show you that. Okay, so we've loaded this image, but we don't know if it really loaded or not. So this is a pointer, and it can be a real address or it can be null. Load image returns a new texture or null. If an error occurred, it's going to return null. Okay, so to test this, it's the same way we tested the window in the render. So I'm just going to yank this code right here. Paste it here. And I'm checking the background. Background, if it's 0, if it equals 0, something went wrong. That's the equivalent to null. And we are having a message error, say loading texture. Okay. And that should be what we need to do. So this should be loading a texture now. We should have this texture loaded. We do need to call this word, this load media word. So I'm going to go down here to play game. After initializing SDL, I can call this load media. Okay, that will load our image up. And then after load media is the game loop. So up here in the game loop, the place that we would draw this image, we have this render SDL, that renders on the stack, but we have this SDL render clear. And then after that, we have SDL render present. So between these two is where we do all of our drawing to the render. So right here, there is a new word that we will use. Sorry, we'll come right back to this. Since I'm already here, we'll do the SDL render copy. So the way that we draw one of these textures that we have to the render is to use SDL render copy. Now this isn't part of the image module. The image module is just for us to load different types of images. Textures and drawing to the renderer is part of the normal SDL module. So this is SDL render copy, and we need a render on the stack, we need our texture on the stack, and then we need a source and a destination rectangle. Okay? The source rectangle is the image we loaded. The image we loaded, whatever we loaded, if we could take just part of that image that we loaded, or we could use the entire image that we loaded. So if we were to put null here, we would get the entire image that we loaded. And that's what I want. I want the entire image that we loaded. And then how we draw it to the renderer, well, we could draw it in different positions on the renderer, and we can draw it in different sizes. It may take up part of the render, the whole render, but for the background image, we want it to take up the entire render. We want it to take everything up. So this image is actually an 800 by 600 image, and the window that we've opened is 800 by 600. So I'm going to take the entire source, and I'm going to display it on the entire render. So both the source rectangle and the destination rectangle are going to be null. Now in a future video, we will be using rectangles because we'll be dealing with smaller images and moving images around. But in this one, we just need to use null for both the source and the destination rectangle. So we're going to have render, our texture, and then null, and then null. Those are going to be on the heap, or the heap. They're going to be on the stack. And then we're going to call this word SDL render copy, and then the answer we get back, we don't care about. It's going to return 0 on success or negative failure, but this is in the game loop. This is happening 60 times a second, and there could be some strange reason why one of the frames that didn't draw, we're not checking. We're not generally checking errors inside the game loop. Loading the texture, it's really important. We're checking the error. But displaying it for one frame, we don't want to shut the game down if it doesn't display one frame. So we're gonna just drop that answer right away. Okay? So render, texture, null, and null, and then we call the word. And we drop the answer. And again, that's going to happen between these two. So we have the render, and then that's the address to the render, and the address to the image is background. That's the address there. And then we have null. And you could put 0 here too if you wanted. But since I've already got a constant up there that's null, I'm just going to use that. And there is our word, and what it leaves on the stack, we don't care about. It's going to leave a 0, but if we ignore this and we don't drop it, our stack will start growing because every frame it's putting another 0 on the stack. So we do need to drop this. And I'll show you what happens if we don't drop it. Okay, so let's just check this out and see if we get a background image. And I've messed something up. So I have image init png constant image flags undefined word. Oh, okay. I know exactly what I did here. So what we've done is we've written all the code probably totally correctly, but we have not required the new module up here. So just like in C or C++, you would need to include SDL and then also SDL underscore image. We need to require SDL2. It's inside the SDL2 folder here, and it's called SDL underscore image.fs. So that's why it was basically saying it didn't know what this image init PNG was. It had not been defined yet. It's defined in here. So it didn't know about it. Okay, so let's try that again. And there is our image. So I know there's a lot of black happening here, so the image is dark, but the reason for this is that this image has a transparent background. So we see part of the color, but the other part is transparent, and that means that we can actually change the background render color later on, and we'll see it. So this shows you how you can do transparency in SDL2 as well. Let's show some errors occurring, And also, I'm going to show you how to, instead of using this kind of word to hold the address, you can actually use a variable as well. So right here, let's comment this out. Okay. And the way that we would use a variable, so what this is doing is this is holding our address directly. It's as a value, because the image being returned, the SDL, it's a pointer to a texture. So that's already a pointer, which is an address. So it's holding an address. If we created a variable, we're going to get an address, but it's the address to the variable. But that variable has a space assigned to it that can hold a value. And then so the SDL texture address would actually be held inside of that value. So this is a little bit confusing. So it's an address to an address. So if we were doing this, we could say variable, and we could say background. And then down here, I could store null in here by storing. So I could say a null background, and I could store it like this. Okay. So this stores null into, which is just 0, into the background. Okay. Now we need to use that. Before we would use a 2. If I was doing this before, it would be null to background. This is null background and then a store operation. Okay. So down here, when we're loading this image, or is it right here? We can't do this here. We need to take off this 2. So and now the address to this texture is on the stack, and we've put the address to the background on the stack, and then we're storing the address to the texture in this background variable. Okay, so that's the store operation, and it's there. Now here we can't use it directly because this background right here is an address, but it's the address to the background variable. It's not the address to the SDL texture. The address to the SDL texture is actually being stored where this background address is pointing to. It's the value being stored at that address. So we need to do a fetch. So it would be background fetch like this. And now that will work. Okay. And one thing that I completely forgot is the cleanup. So I know we glossed over it right here, but it's the SDL destroy texture. Again, this is part of SDL and not part of image because the texture is just part of SDL. Only the PNG part is part of the image. So this SDL destroy texture is how we clean up after ourselves with the texture. So up here, we would need to do the same thing. We would say background. We put the address of the variable on the stack, but we need to fetch what background is holding, which is the address to the texture, and then we're going to call SDL destroy texture. Okay, and then to set it to null, we would say null background and then store. Okay, so let's check to see if I got all of that right. I hope I did. And I messed one other thing up too, and I'm going to show you what I just messed up. Because I want to show you an error, but when I go to show you the error, I actually made a mistake. So this is the mistake I made. So if I were to spell this wrong right here, it should shut down if I did it right, which I didn't do it right. And maybe you could spot the error here that's happening. But if I misspell this, do you think that the program is going to shut down and give me an error message? Or do you think that the program will just continue run without an image? So let's see what happens. And it didn't shut down and give us an error message. It just ran. So the reason why is our check. This check right here is checking to see if this is an address, and it is an address. It's the address to the variable. It's not the address to the texture. So we have to do a fetch here. And now this should fail. There we go. So error loading texture. So that already happened. That error happened. It's just we never captured it. Instead, our check was checking to see if this was an address, and in background is an address. It's an address to the variable background, which stores the 0 on the failure, so we need to fetch that. So that's how, if we wanted to use a variable, and that's also what it looks like here. And I can tell you that it exited badly because I can echo status. So echo status is the equivalent to echo $? In bash. I'm in fish, so I'm not using that. So it'd be like this. And it basically tells us, hey, what was the exit code of the last program you just ran? But for me, it's going to be status. And it's 1 because an error occurred. Now, if I were to do this again, I would get 0 because now it'd be checking the status of this echo command, right? So let's fix this right here, and then we'll check again the error, or the status of that close. So now it should run, yes, and we're closing it. Now if we check the status, 0. 0 is the good status. So we are sending the error code properly. I'm going to switch all of this back now to the other way. So I'm not going to use the variable. I'm going to use the word one, which I don't know the proper name for it. I think it's just a word with a value. But I can use it directly because this background is the actual address to the texture now. Or before, the background was the address to the variable. The background is actually just a value now, which is the address of the texture. So down here, I need to remove this fetch. And in the cleanup, I need to remove it. And this also needs to be null2 without this store. And up here, I'm going to remove these and uncomment this. And that should still work now, unless I missed something. Oops. Okay, and check the status, and it's good. And I'm going to cause an error real quick just to make sure. Here. Okay, and that's the error message that we should see, so everything's working correctly. Okay, so let's change this title up here to background. And I'll run it one last time. And it says background up there. That's good. Okay, so let's just walk through what we have. So we needed to require SDL image FS to get us access to all the image things going on, and we stored our flags in a constant here, so that you can, again, if you wanted to do 2 of them, you could put 2 of them on and an OR. If you wanted 3, you could do 2 and OR, add a third one, and then OR it again, and then save it in a constant. That would allow you to chain together multiple, and that's the same for up here. However, this one doesn't check them the same way, but they're still ORed together the same. This SDL init doesn't return flags. It just returns failure, whereas image init returns flags. So that's why this funny sequence of events, we put on the stack what we want, we call the word, now we mask it against what we wanted, and then we put what we wanted back on again and see if it's not equal to that, the final answer, if it's not equal. So that's the way we bring image online, and then we're bringing image offline here, right above where we did the SDL, because it's last in, first out. Now we have access to the image module. We are loading things with image load texture, and this loads it directly to a texture, not to a software rendered surface, but a hardware rendered texture. So we need the render, we need a CSAL string to the actual file, which is right here. We are storing that in background. We are checking if this background is a good address or 0. If it's 0, there's a problem. And then the way that we're drawing it is with the render We throw the render on the stack, we throw the background on the stack, and then we're using null for both the source and the destination rectangle because we are allowing this to take up the whole screen. And I'll show you, we can stretch this. Let's change it to 1200 by 200, and we're going to see that the image is going to be stretched to the screen. Okay? So this is, it's wonky, but it's correct. It's saying, yeah, the destination rectangle is the same as the render. So I'm going to switch this back to 800 by 600. And the way that we deal with the texture to clean it up is SDL destroy texture for the background, and we're setting the background to null afterwards. And I think that's everything. And we've changed the title to background. Okay, so that is the way that you load an image. That's the way that you bring the image module online, and that's the way you load a image to a texture directly, and the way that you display it to the render. Okay, so I hope that was educational or entertaining, and I will see you in the next one. Bye.